G'day! In this lesson we will implement the author's application layer. We will first create the application service interface and the related DTOs. Let's create a new interface named iAuthorAppService in the authors folder of the application.contracts project. We will replace its content with the following code. The iApplication service is a conventional interface that is inherited by all the application services, so the ABP framework can identify the service. We have defined standard methods to perform CRUD operations on the author entity. Some methods return page result DTO, which is a predefined DTO class in the ABP framework. It has an items collection and a total count property to return a page result. The other methods return an author DTO for the newly created author from the createAsync and getAsync methods. While it is not used by this application, it's just there to show you a different usage. Let's create the DTOs one by one. First, we will create the author DTO in the authors folder of the application.contracts project. We will replace its content with the following code. The entity DTO of type T simply has an ID property with the given generic argument, in this case GUID. You could create an ID property yourself instead of inheriting the entity DTO of type GUID. Let's create the getAuthorSList DTO in the authors folder of the application.contracts project. We will replace the contents with the following code. The filter property is used to search authors. It can be null or an empty string to get all the authors. The getAuthorSList DTO inherits the paged and sorted result request DTO, which has the standard paging and sorting properties, like max result count of type int, skip count of type int, and sorting of type string. ABP framework has such base DTO classes to simplify and standardize your DTOs, again to make our life easier, of course. Let's create the createAuthor DTO in the authors folder of the application.contracts project. We'll replace its contents with the following code. Notice the data annotation attributes which are used to validate the DTO, specifically the required and the string length attributes. Let's create the update author DTO in the authors folder of the application.contracts project. We'll replace the contents with the following code. We could share and reuse the DTOs among the create and update operations. While we could do it, we prefer to create different DTOs for these operations. In a real-life project, we will generally see them to be different by the time we are done with the application. So, code duplication is reasonable here compared to the tightly coupled design. It's time to implement the iAuthorAppService interface. Let's create a new class named AuthorAppService in the authors folder of the application project. The authorize attribute with the argument bookstorePermissions.authors.default is a declarative way to check a permission policy to authorize the current user. We will define the permissions in the bookstore permissions class in a moment. Don't worry about the compile error for now. The author app service is derived from the bookstore app service, which is a simple base class which comes with the startup template. It's derived from the standard application service class. The author app service implements the iAuthor app service which was defined above. The iAuthor repository and the author manager are injected in as service methods to be used by the author app service. Now we will introduce the service methods one by one. Let's add the getAsync method using the following code. This method simply gets the author entity by its ID, converts the author DTO using the object-to-object mapper. This requires us to configure the auto mapper, which we will do in a moment. Let's add the getListAsync method using the following code. The default sorting is by author name, which is done in the beginning of the method, in case the user didn't specify anything. We have used the iAuthor repository.getListAsync to get a paged, sorted, and filtered list of authors from the database. We had implemented it in the previous lesson. Again, we don't need such a method since we could directly query over the repository, but wanted to demonstrate how to create custom repository methods just in case you do need them in your real-life application. We also directly queried the author repository while getting the count of the authors. We prefer to use the async executor service, which allows us to perform async queries without depending on the EF core package. However, we could depend on the EF core package and directly use the author repository.whereif.toListAsync method. Finally, the getListAsync method returns a paged result by mapping the list of authors to the list of author DTOs. Let's add the createAsync method using the following code. The createAsync method requires the bookstorePermissions.authors.createPermission in addition to the bookstorePermissions.authors.default declared for the author app service class. We have also used the author manager, which is the domain service, to create a new author. The iAuthorRepository.insertAsync method is used to insert the new author into the database. The object mapper is also used to return an author DTO representing the newly created author entity. Some developers may find it useful to insert the new entity inside the authormanager.createAsync method. We think it's a better design to leave it to the application layer since it knows when to insert it into the database. Maybe you require additional work done on the entity before insert, which could require an additional update if we perform the insert in the domain service. However, it's completely up to you. Let's add updateAsync method using the following code. The updateAsync method requires the additional bookstorePermissions.authors.editPermission. We have used the iAuthorRepository.getAsync to get the author entity from the database. GetAsync throws entity not found exception if there is no author with the given ID, which results in a 404 HTTP status code in our web application. It is a good practice to always use the getAsync method to retrieve the entity that we're going to perform the update operation on. We have also used the authormanager.changeNameAsync, which was defined in the domain service method to change the author name if it was requested by the user. We have directly updated the birth date and short bio since there is no business rule to change these properties. They accept any value. Finally, we call the iAuthorRepository.updateAsync method to update the entity in the database. Entity Framework Core has a change tracking system and automatically saves any changes to an entity at the end of the unit of work. We can simply think that the ABP framework automatically calls save changes at the end of the method. So it will work as expected even if we don't call the authorRepository.updateAsync at the end of the method. If you don't consider to change EF core later, you can just remove this line. Let's add deleteAsync method using the following code. The deleteAsync method requires the additional bookstorePermissions.authors.deletePermission. It simply uses the deleteAsync method of the repository to delete the author in the database. But remember, it will just do a soft delete because the author entity inherits the full audited aggregate root of type GUID. We can't compile the code yet. It is expecting some constants declared in the bookstorePermissions class. Let's open the bookstorePermissions class inside the application.contracts project in the permissions folder and add the following code after the permissions for the books. We then open the bookstorePermissions definition provider in the same project and add the following lines at the end of the define method. Finally, we add the following entries to the localization/bookstore/en.json inside the domain.shareds project to localize the permission names. The author app service is using the object mapper to convert the author object to the author DTO object. So we need to define this mapping in the auto mapper configuration. Let's open the bookstore application auto mapper profile class inside the application project and add the following line of code to the constructor. This basically maps the author to the author DTO. As we did for the books before, it would be good to have some initial author entities in the database. This will be good while running the application for the first time, but also it will be very useful for the automated tests. Let's open the bookstore data seeder contributor in the domain project and change the file contents with the following code. We can now run the .db migrator console application to migrate the database schema and seed the initial data. Finally, we can write some tests for the author app service. Let's add a new class named author app service _tests in the authors folder of the acme.bookstore.applications.test project. Let's replace the contents of the author app service _test class with the following code. We will now add the tests one by one. First, let's add the test to get all the authors without any filter. Now we will add a test to get filtered authors. We need a test which should create a new author. We also need a test that a duplicate author is not allowed. These tests are pretty self-explanatory. If you have any questions or comments, ask your questions in the comment under this screencast. In this lesson, we created the author's application layer. Join me in the next lesson where we will create the author's user interface.